Okay, so let me start where I stopped last time. Today we are going to discuss how to compute mean, variance in terms of probability. When probability distribution of a random variable is given, how to compute that. And then we will compute some probability problem. Then we will solve a contingency table problem, and we will use set theory there. And after doing all of these computations, then we will start discussing some probability distributions. Okay, so let me start how to compute mean and variance. Okay, how to compute mean and variance. So suppose this is a data approach. If data is given, how to compute mean and variance, and this is a random variable approach. Random variable approach. So what is data approach? Suppose you are given 5, 9, 10, 15, 6, 7, 11, 19, 14, 9, 10, 6. These are the data points are given. Okay. And then how can you find the mean? Mean you can find by using sum of xi over n. Okay. How can you find the variance? Variance you can find 1 over n minus 1 sum of xi minus x bar square. This is the way you can find mean and variance. This is the definition of mean, and this is the definition of variances when data points are given, right? Now, if you are given random variable, for example, a die tossing experiment, x equal to what? X equal to number appears when a dice is tossed, right? Number appear when a dice is tossed. How can you write that? X equal to 1, 2, 3, 4, 5, and 6. And what is the probability of x? 1 over 6, 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 1 over 6. Okay. How can we compute mean and variance in terms of a random variable approach? So data approach is this. Now random variable approach is mean is written as expected value of x, which could be written as sum of xi p of xi. I goes 1 to 6. Then you plug value 1 time 1 over 6 plus 2 time 1 over 6 plus 3 time 1 over 6 plus 4 time 1 over 6 plus 5 time 1 over 6 plus 6 time 1 over 6. Understand? Are you understanding? So now, if you want to find this, how can you do that? 6, then 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is equal to 21 over 6. So that means 7 over 2, which is equal to 3.5. Are you understanding? So average value or expected value of x equal to what? What is x? What is the definition of x? What is the definition of x? X stands for what? What? You have to loud. I don't know. Yeah. Data for what? X stands for what? Independent variable, understand. X is independent variable. Yeah, it is right because you are tossing the coin. X stands for numbers appears on a die, right? X is a number that appears on a die. So I want to find if you toss a die on an average, what number will appear? Do you understand? Anything mathematically written or mathematically anything is derived, that should have an explanation, right? So what is the explanation? If you toss a dice on an average, 3.5 will appear. So sometimes expected value does not make sense, right? Are you understanding what I said? Is there any number 3.5 in any dice? No, right? Are you understanding? Purposely, I took this example to convince you that sometimes this average value does not make sense because each element has a chance of appearing any of these 6 numbers. So sometimes it will be 2, sometimes it will be 3, sometimes it will be 6. So the numbers that are you are getting, if you average them on an average, what would be the average of those numbers? That is what you are trying to find. But 3.5 does not make sense. Understand, right? Okay. So now what is the variance? How can you find the variance for this approach? Variance for this approach is this. Variance of x equal to expected value of x square minus expected value of x whole square. So expected value of x square means 1 square times 1 over 6, 2 square times 1 over 6. Again, you can write it here, sum of x square and p of x. And this is already you have found, which is equal to 3.5 square. Now you can write these things 1 over 6, 3 square over 1 over 6, 4 square over 1 over 6, 5 square over 1 over 6, 6 square over 1 over 6, minus 3.5 square. 3.5 square equal to what? Let me check. Um, 3.5 square, 12.25. Here is I have 12.25. Okay. So now if I want to write here 1 over 6, then we have 1 plus 4 plus 9 plus 16 plus 25 plus 36 minus 12.25. Okay. So now let me consider this 61, 61, 77, 77 and 87, 87, then 91. 87, 91. So we have 91 over 6 minus 12.25. Let me check how much we have in there. (91) divided by 6 minus 12.25 equal to 2.91 equal to 2.91. So what we learned today? They already activated the heater, so that is why you are feeling so hot in the room classroom, right? I really feel very hot, but unfortunately, I just have one of these. If I have another T-shirt, then I should take off this my shirt. Because this shirt is a very thick shirt. So in 12 minutes so far, what we have learned, what we have refreshed our head, how to compute mean and variance by two approaches. One is data approach. When data is given in this format, data is given in this format, how to find mean and variance. When data is given in terms of probability distribution, that is random variable together with probability, then how to compute this mean and variance. You understand, right? You understand, right? So mean and variance formula will be different based on the data is provided. If data is provided only in the data points, then you have to use this. If data is provided in terms of probability distribution, that means values of the variable together with their associated probability, this is the mean and variance formula. Clear? Clear, right? Okay, so I think you never would have a problem if you understand these things. My experience is telling me, even after providing these things, if I give a data, like in a class of like 40 students, I told that multiple times during the exam, if I ask them find the mean and variance of the variable X, they just find the mean and variance by data approach, not by the random variable approach. Clear, right? So I clarified these things. Okay. So let us do some independence. What is independence? Independence. What do you mean by independence? Okay, let me write here two events A and B are said to be independent if joint probability of A and B equal to the multiplication of the individual probability. I will give you an example, then you will understand, okay? This is the definitions of joint probability. You remember in the set theory, I discussed, right? A and B. A and B is written like A and B, right? When I discuss the set theory, this is the notation, right? A and B. A or B is written like A union B. When I discuss set theory, I discuss these things, right? This Either you can write like that way or you can write like that way. For example, I can write here probability of A and B equal to probability of A times probability of B. Clear, right? This is what two events A and B are said to be independent. In your next exam, it will be similar to your first exam when there are 10 questions and multiple choice things, you answer those things, right? So in this case, I will ask you check whether two events A and B are independent or not. And if they are independent, you have to find the left-hand side. This is called the left-hand side. Left-hand side, and that is called the right-hand side. You have to check whether left-hand side equal to right-hand side or not. Clear, right? Okay, now let me give you an example. In a community, see, in a community, there are 500 people. In a community, there are 500 people. People, 300 of them are minor. Okay, 300 them of are minor, and 200 of them are players. $100 of them are both minor and player. Construct a 2x2 contingency table. Construct a 2x2 contingency table and compute following probabilities. And okay, so now 2x2 contingency table. Okay, suppose a person is selected from this community. Find the following probability. Selected person is a minor. Number 2, selected person is a non-player. Selected person is a minor, selected person is a non-player. selected person is a player or adult. Check whether check whether player and minor are independent. Independent or not. Selected person both. Selected person is a player and minor. Okay. Number 6, conditional probability, which I am going to conditional probability. Selected person is a player given that he is a minor. These 6 problems we are going to do. See what I have covered in this problem: how to check independence, how to use set theory, and how to find conditional probability. Usually in this exam, at least 1 or 2 problems you are going to get from this. Maybe 2-3 problems you can get from this. Understand, right? Clear, right? So now first task is what? First task is to construct a contingency table, okay? Let us construct a contingency table. So let us solve this. Let us answer each of these. Let us construct contingency table. So I write here player, and there I put here non-player. I put here minor, and then I put here adult. Then I write like this. Total. So how many people altogether? 500, right? In a community, there are 500 people. 300 of them are minor. 300 of them are minor. So how many adults? 200. Okay. 100, 200 of them are players. 200 of them are players. How many non-players? 300, right? Let me see whether I can do that one now. 100 of them both minor and player. 100 of them are minor and player. Minor and player, then it should be 100. Then it should be 200. It should be 100. Understand? Clear, right? Okay, if you have a trouble, let me show you again. Did you understand these things? Did you understand, or I need to show you again? This girl, are you okay? Are you understanding? Are you okay understanding? So I don't need to show. Okay, good, good. So that's the way you have to do the contingency table. Remember, in your exam, if you see this type of word problem, first task is to construct a contingency table. That means you did 95% of the work. Rest of the thing just observing, reading the table and solving the problem. Understand? So contingency table here, I just put 2 category in the column and 2 category in the row. Column has player and non-player, and rows has minor and adult. Okay, 2 by 2 categories, so it is easier. In the exam, you might get 3 by 3 or 4 by 3, and then writing is long, right? Writing will be wrong, because if 3 by 4 category, that means there will be 12 cell. Now there are 4 cell, 1, 2, 3, 4, 4 cell. But if there is a 4 by 3, 12 cell, lot of writing. So you have to keep your temperament super cool when you read the question in order to accurately write contingency table. Once you accurately write, perfectly write contingency table, rest of the problem is super easy. Clear, right? Because in your exam, you will get a problem like that. So that is why I spent some time. Okay, first of all, let's solve problem now. What happened? So contingency table is constructed. So we can write here, the above table is the contingency table. The above table is a contingency table. Above table is a contingency table. Okay. After that, suppose a person is selected from this community. Find the selected person is a minor. Selected person is a minor. Can anyone of you tell me how can I find the selected person is a minor? What will be the probability? Selected person is a minor. What is the probability?
3/5.
What?
3/5.
3/5, because 300 minor, 500 total people. So this should be 3/5. Are you understanding? Are you okay? Number 1 is gone. Now come to number 2. Number 2 is selected person is a non-player. Selected person is a non-player. Again, 300 over 500, right? Right? So number 3 is telling you selected person is a player or adult. Player or adult. See, in this case, yes. Use decimal expression. Okay? Decimal expression. For example, if you do this thing, this will be 0.6, right? Thank you for asking this question. Please, probability always expressed in terms of decimal number. Okay. Number 3, they are asking, find the probability selected person is a player or adult. Selected person is a player or adult. Player or adult. So you can write probability of player plus probability of adult minus probability of player intersection adult. Remember set theory, I have discussed this probability problem, right? In the set theory. You remember that? In the set theory, I have discussed that things. Probability of A union B. Probability of A union B I discussed in the set theory. Okay? So write down all the notes because your exam will be open book, open note, and it will be an online. 20 questions is coming. So you can solve all of these things by reading the material, watching my video will be the best to do well in the exam. And you have the link, right? I send you the link, right? The YouTube link, right? Yeah. So you can subscribe those things. In that way, you will never lose anything. New materials will be uploaded. It will automatically give you a notification. Okay, now probability of player. Player equal to what? Player equal to 200 over 500. Probability of adult. Adult equal to what? 200 over 500. And probability of player and adult. Player and adult 100 over 100 over 500. Clear, right? Are you understanding or not? Let me show you the table. That is the table. When you see the word or, and at least, these are the same thing. At least and or are the same thing. Clear, right? So now, if you want to do these things 500, then 300. So this is 3 over 5. Understand? This number I just randomly choose from my head, so that is why 3 over 5th is coming. So you might ask me a question, why all time 3 over 5th? Because this number just is randomly coming from my head, so that is why. Okay. Number 4. What is number 4? Check whether player and minor are independent or not, right? So this is what we have to check. We have to check probability of player and minor, player. This is the left hand side equal to right hand side. Okay, we have to check whether player and minor are independent or not. So I want to write left hand side, which is equal to probability of player and minor. And probability of player and minor here is 500 Player and minor equal to 100, right? Player and minor equal to 100. So I put here 100, then I got 1/5. Now right hand side, which is equal to probability of player times probability of minor. Now probability of player 200, probability of minor 300. So this is 200 over 500. This is 300 over 500. So we have here 6 over 25. This. 6 over 25. Okay. So this is equal to 0.20. This is equal to 60. 0.24. Okay. Are they same? Are they same? No, right? Left hand side is not equal to right hand side. Clear? So 0.20 is not equal to 0.24. Understanding? Okay. Now I have to discuss conditional probability. Let me see now. This is the problem number 4. Selected person is a player and minor. Selected person is a player and minor. So number 5. Selected person is a player and minor. Player and minor, which is equal to 1/5. Player and minor equal to 100. Player and minor equal to 100. So now number 6 is called the conditional probability. Okay. What is the meaning of the conditional probability? Conditional means when you were a kid, you told your dad, I'll do this math if you buy for me something. You give the condition, right? Or your mama give you the condition, okay? Do these things, then I will buy something for you. So that means she gave you some condition, right? That means some information is already given to you. So condition means some information is already provided. So that is why if you take a look, given that selected person is a player, given that he is a minor. What is given? Minor is given, right? Understand? Condition. He is a minor. That is the given. That is the condition. So it has a notation. Conditional probability has been written like this way. This is the condition. After this vertical line, what is given, that should be written. Understand? After the vertical line, what is given, that should be written. My teaching experience telling me, some students, they switch up. They do not know which one to put after the vertical line. What is given is coming after the vertical line. Understand? Clear, right? What is given, that must come after the vertical line. So what is given? Given is that, given that he is a minor. Given that he is a minor. This is the minor. And this is the player. So probability of player intersection minor, God bless you, divided by probability of minor. So probability of A given B, B is given what is the chance of happening A. The notation is this, probability of A and B like probability of B. If you want me to draw picture for this one, I can write here. This is my A. This is my, I want to give the B. This is my whole thing is B. So this is A, this is C, this is D, this is E. Okay? And B is what? B is this entire thing. This B is entire thing. Understand? So B is entire thing. What is the chance? Maybe I can give you the better example. For example, okay, this could be, and then in terms of Bayesian thing, I can put like this way, but that will be little hard for you. But just remember these things. B already happened, B already given. How can you compute that? So this is my entire B, and what is the chance that only this part will happen, only A will happen. So that is the way it is written. Okay. So now come here, player and minor 100 over 500, and probability of minor is just 300 over 500. So that means 1/3. That means 1/3. Let me drink little water. Maybe if you want, you can take 5 minutes break. Let me quickly come back from my office room. Okay, so we spent 5 minutes, actually more than 5 minutes. So now let us solve a problem where combinations will be used to compute probabilities. Okay, so remember this is called the contingency table problem. These contingency table problems you will expect in the exam, but you have to draw your own contingency table by reading the problem like the way I have written the problem in here, right? I have written the problem in here. This is all the way I have written. In the exam, I will write a problem similar to that. You have to draw a contingency table. From there, you have to solve this type of problem. So everyone now understand what is conditional probability, right? Conditional probability means something already happened. What is the probability that new things is going to happen? Okay. The selected person is a minor given that he is a player. Okay. Now we want to compute probability from combination problem. So computing probability from combination problem. After doing this, then we will go for probability distribution. A ball has 20 marbles of red, white, black, and red, white, black, and pink colors. God bless you. Okay. Seven marbles have been drawn from the ball without replacement. A ball has 20 marbles of red, white, black, and pink colors. 7 marbles have been drawn from the ball without replacement. Without replacement. It should be mentioned that 8 are red, 5 are white, 4 are black, and 3 are pink. It should be mentioned that 8 are black, 3 pink marbles. So 8 of the marbles are red, 5 are white, 4 are black, and 3 are pink. Clear, right? So 8 are red, 5 are white, 4 are black, and 3 are pink. So that means 20 marbles. Okay. So altogether 20 marbles is in there. Find the probability that how many marble we have selected? 7, right? Find the probability that all 7 are red. 4 are red, 2 are white, 1 is black. Three are red, 2 are white, 1 is black, 1 is pink. Three are red, 2 are white, 1 is black, and 1 is pink. All 7 are white. Four are red. 4 are red. And 3 are from each of the remaining colors. You are understanding, right? Solution. Seven marbles can be picked choose 7, right? Does ordering matter in here? Marbles in a box, right? The questions does not imply anything, so that the order doesn't matter in here. I'm just randomly picking 7 marbles, right? So 20 choose 7, which could be written as factorial 20, factorial 7, factorial 13, right? Clear, right? Let me see if I can find anaconda. I forgot how to write combination. Nowadays, you have to learn a lot of things. So it is almost impossible for you to memorize lot of coding, lot of things in your head. I use Python, I use SAS, I use R. So I do not know the, I have to check in online. Let me check in there. Combination codes. combination codes for combination code in Python. Let me see what this permutation. I need a combination one. I think that one. This one. So import math. I have to import the math. Import math. So let me import math and then these things. And here I want to change here 7. I have to change here 20. That's it. Let's see. Oh, 20. Control enter. What happened? Okay. So I got here 77520. Okay. 77520 math.com. Math.com. Copy. Just put here. Control V. 77520. Okay. Math.com 20 and 7. So that is 77520. So the answer is in here. Seven 77520, right? 77520. Okay. Now, first question. All 7 are red. All 7 are red, which could be obtained 77520. All 7 are red. This is the denominator. So how can you 5 7s are red? What would be the numerator? Can any one of you help me? I'm finding probability, right? All 7 are red. What will be the numerator? Denominator will be 77520. Can you? In the numerator, it will be only red marble, 7 red marble. So 7 red marble can come only from the 8 red marble, right? So that means that should be 8 choose 7. 8 choose 7 equal to 8. How? Take a look at that. If you write here, then write here 8 and then hit enter, see 8. Math.com. That is equal to 8. So that means this 8. Now, if you can ask me question, how is this possible? So red marble, right? You can write here red 1, red 2, red 3, red 4, red 5, red 6, red 7. Then red 1, red 2, red 3, red 4, red 5, red 6, red 8. Okay? Now come here, red 1, red 2, red 3, red 4, red 5, red 7, red 8. So 6 is not in there. Now again you can do red 1, red 2, red 3, red 4, red 6, red 7, red 8. So this is the way, if you list all of this, you will get 8 different types of red marble. So this is the answer. So your answer will be 8 divided by 77520. Eight divided by 77520, which is equal to 0.000103. Are you getting it or not? Just I want to give you a piece of advice in your life. I'm teaching graduate class as well as undergraduate class, understand? Try to learn everything by hard work. Ultimately, you are continuously evaluated by your peers. So your professor, your friend, your mom, your dad, your spouse, your wife, all of them. I gave an exam to the graduate class and I specifically mentioned what to give. I was honest with them, but if they do not perform well, and even after the exam, I asked them, give it to me, and they cannot provide. Someone else do work for them remotely online from another part of the world. Are you understanding? Because it is open book, open note exam, internet is open, everything. And then you are taking help from outside of the world, and then you got caught. You understand, right? If these type of things happen as a professor, if I permit these things, if I will be caught, then I will be fired from there, right? So US is a country where you can flourish. Just do the hard work. Lot of opportunities. There is not a limited opportunity like my country, Bangladesh, or some other small country. Limited opportunity. You have to be top 1%, top 1%. There are a lot of companies, lot of opportunities. If you work hard, you can go up. And throughout your life, be honest. Because I hear a noise in there, and then I see that, and then what he said, I just want to pass this information to you. Most beautiful weapon on the earth for each person is the truthfulness and honesty. Understand? Believe me. Truthfulness and honesty, these things you have, all of the people in your surrounding, gradually, they will love you. Gradually, they will love you, they will like you because they depends on you. Why they depends on you? Because you are honest, you would not harm them, you would not drag them down, you will always help them to the people. Kindness, honesty, and truthfulness should be the unique characteristics every human being should try to achieve. Okay, so the reason I just spent 1 or 2 minutes, because there is a reason. Okay. 4 are red, 2 are white, and 1 is black. How can you do that? So 4 are red, 2 white, 1 black. How can you do that? Denominator is this one. 4 red, 2 white, and 1 black. Can anyone of you help me? Four are red, right? How many red was in there? 8 red, right? So option 1. So I want your opinion. Option 1 and option 2. Option 2. So denominator is as it is. Denominator is as it is. So there are 4. 8 choose 4, right? 8 choose 4. 5 choose 2. 4 choose 1. So there are 4 black, right? 4 black. Okay, now I want to write here 8 choose 4, 5 choose 2, 4 choose 1. Now see, is this a multiplication or is this a addition? Do you understand my question? Is this the addition or is this the multiplication? So now I want to have your opinion. It should be addition or it should be multiplication. What is your opinion? You have to choose one of the two by using your intuition. What would be your choice? Addition or multiplication? Multiplication. How about you? Multiplication. Because his voice is very high, he is a man. No? Gentlemen, what is your opinion? How about you? This girl. Multiplication. Multiplication? How about you? Nobody with me. How about you? Multiplication? My goodness. All of you outnumber me. Yes, it is multiplication. It is multiplication. Do you know why? Why multiplication? Why multiplication? Can anyone of you tell me? Give me the formula that I discussed. After the first exam, when I start discussing second exam material, what did I discuss? First day of the class. First day of the class, what did I discuss? BPC. BPC, you remember? Basic principles of counting, right? BPC. BPC. Basic principles of counting. Right? 4 red and 4 red, 2 white, 2 white, and 1 black. Right? So 4 red could be red 1, red 2, red 3, red 4. And it could be red 1, red 2, red 3, red 5. There are 5 red. And then there should be red 1, red 2, red 3, red 4, red 5. 2 white. It could be white 1, white 2, white 1, white 3, white 1, white 4. Because there are 4 okay. There are 5. So white 1, white 2, like white 1 and white 5. So red 1, red 2, and then it will go red 1, red 2, red 3, red 8, something like this. All of this it can go. And here is 1 black, just 4 choose 1 black. Black 1, black 2, black 3, black 4, right? Then it can go like this way, that way, this way, that way, this way, this way, that way, like this. It is a multiplication coming from basic principles of counting. That's why people would have a confusion. In order to avoid these confusions, any undergraduate and graduate level books that starts with the probability, that discusses probability, at least 3-4 lines, graduate level, advanced graduate level book, 3-4 lines, they write these basic principles of counting, the multiplication one. Understand, right? So even PhD level books, when they start discussing probability, they first start with the BPC, basic principles of counting. Clear, right? Okay. So now, so this is the answer. This is a wrong. This is a wrong. It is a multiplication. So the answer is this. So if you multiply these things, then you will get the result, which will be the answer. So how can you do these things? Let me find this. This is 77520. Let me find this by using that one. 8, choose 4. 8, choose 4. 70. 8, choose 4 equal to, I got the 70. So that is equal to 70 times 5, choose 2 equal to 10, I guess. Yeah, 5 choose equal to 4, choose equal to 4. So 800, 7,520. Okay. Then you will divide it 2800 by 2800 divided by 77520 will give us this. Okay. Three are red, 2 are white, 1 is black, and 1 is pink. 3 red, 2, 3 red, 2 white, 1 black, 1 pink, which could be obtained by 8 combination of 3, 4 combination of 2, 3, 5, 4 combination of 1, 3 combination of 1. 3 is pink, right? 3 pink. Yeah. Yep. Divided by 77520. Okay. Eight choose 3. Let me find 8 choose 3. 56. That is equal to 56. This is equal to 10. That is equal to 4. That is equal to 3 divided by 77520, which we can obtain 56 times 10 times 10 times 4 times 3 divided by 77520, 77520. 0.0866, 0.0866, 0.0866. So if you become expert on this Python code, math.com, then it will be easier for you to compute this probability, okay? You will definitely get one question from these combinations and how to compute probability by using combination. How to compute probability by using combination. Four are red and 3 are from each of the remaining color. So 4 are red, 4 red, 1 white, 1 black, and 1 pink, which could be obtained 77520, 8 choose 4, and then 5 choose 1, 4 choose 1, 3 choose 1. Okay. So 8 choose 4 equal to 72 or 78 choose 4 equal to 70, 75, 4, 3, 7, 7, 5, 2, 0, which will give us 7543. 7, let me put a parenthesis there. 7 times 5 times 4 times 7, 4 times 3. Let me put a parenthesis there. Divided by 5, 5, 7, 7, 7, 7, 5, 2, 0. 7, 7, 5, 2, 0. 0.0750, 0.0750, 0.0750. That is the answer. Go back to the question. Here. Oh, 97. Why did they put 97? It should be 70, right? Oh, I know now why there is 97, because when I press on the parenthesis sign, 9 appear. Okay. Okay. So, are you familiar with the cards? Cards? Do you do a lot of gambling? So you don't know cards? Poker, like cards has a heart, and then clubs, diamond, and what is another one? Hearts, clubs, diamond, What? Spade. It has 13 cards, 13 cards, 13 cards, 13 cards, right? What is this 13 cards? This is from 2, 3, 4, 5, 6, 7, 8, 9, 10, Joker, Queen, King, H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Anyone in this classroom are not familiar with the card? So everyone familiar, right? Everyone familiar, right? Okay, so then let us solve one problem by using card, then we are done. Next class, I will cover probability distributions. 3 probability distribution next class I will cover. Next week will be our 11th week, right? 11th week, then 12, 13, 14, 15. Test of hypothesis 2 class and regressions 2 class, 1 class, and okay. A deck of card contains 52 cards with name, heart, clubs, diamond, and spade. Suppose 4 cards are drawn. 4 cards are drawn. Find the probability that all are kings. All are red. All are red. All are diamond. Okay? All are diamond. All are kings. All are red. All are diamond. 1 from each type. 4 types of card. 4 types, 1 from each. 2 from red, 2 from red, and 2 from black. 5. 3 from spade and 1 from other. 1 from other. Okay. So I just want to solve it in here. Can anyone tell me how can I solve this? What will be the denominator? So denominator will be 52, choose 4. And numerator? All are kings. So that means there are 4 kings, right? So 4 choose 4, right? So that is 4 choose 4, which is equal to only one way, right? 4 choose 4 means only one way. (52) choose 4. The answer will be if you write here math.com and then 4 choose 4, it is just 1. And then numerator will be math.com 52 choose 4. Very small probability, 6 zeros. So the probability equal to 0, 0, 0, 0, 5, 0, 5, 0, 3, 6, 9, 3, 6, 9, 5, 0, 3, 6, 9. Okay. All are red. All are red. Denominator is 52, choose 4, right? All are red. How can you do that? How many red cards? That girl, how many red cards? You don't know? In the deck of cards, how many cards? Total 52. Yeah. How many red? Half. So then how many cards I'm choosing? 26. So that means that should be 26, choose 4, right? All 4 cards are coming from reds, right? Are you understanding or not? What was the question? Question was that suppose 4 cards are drawn, 4 cards. Find the probability that all are red. That means all 4 are red. So that is why 26 choose 4. Do you understand? Are you okay or not? Clear, right? So what would be the answer for that one? Looks like few of you are confused maybe. Are you okay? You are understanding now? Or you have a question? You don't have a question. Everyone is okay, right? So I am choosing how many 4 cards and I want to find that all 4 cards are from red color. How many red color? 26 red color. How many black color? 26 black color. So the answer is 0.0552. Answer is 0.0552. 52 choose 4. All are diamond. This boy in the back, all are diamond. How can you do that?
It's all diamonds go to hearts as well. It's like people, it's,
13.
Yeah.
So then 13 choose 4, right? Right? 13 choose 4. Point 0026. 0.0026. One from each type. How can you do that? One from each type. 52 choose 4. So 13 choose 1. 13 choose 1. 13 choose 1. 13 choose 1, right? Right? So that means you have to do it in here. Thirteen choose 1. And then let me do these things like that way. Get rid of that. 13 choose 1 equal to 13. So times 13 times 13 times 13. 0.1054. 0.1054. Two from red and two from black. Two from red and two from black. 26 choose 2. 26 choose 2. 52 choose 4. Two from red and two from black. Twenty-six choose 2. 26 choose 2. Twenty-six choose 2. math.comd.com, and I have to multiply it by 2 as well. 2 times. Let's see whether it will work. Yes. Point 0024. 0.0024. So 3 from spread to a 13, that should be written like it should be done 52 choose 4, 3 from spread, 13 choose 3 times 39 choose 1, right? Here is the answer, 0.0412. 0.0412. 0.0412. 0.0412. Clear, right? Okay. Here is the thing. So let me show you what is my plan. So I started to cover BPC. Okay. Then I covered factorial and give you rationale why factorial 1, factorial 0 equal to 1. Then I discuss permutation. In discussing permutations, I solve problem by the word egg, by the word says, by the word lal, right? You remember that, right? Then I also solve the problem by using word volume, right? Right? And then permutation is done. I gave also you example how to compute, how to arrange the different letters of the word Mississippi, Tennessee, mathematics, statistics, right? So permutation, combination. After doing this, then I discuss set theory, right? I discuss set theory. I discuss sample space. And how to compute like 4 die and 6 coins are tossed. How many sample points? How many sample points in the sample space? You remember that? You remember that? How many? Can anyone of you solve this? 4 die and 6 coins are tossed. How many? One problem after discussing that thing, I solved one problem in the class. 4 die and 6 coin has been taken and tossed. How many sample points in the sample space? Four die, right? 1 die, that many sample points. 2 die, that many sample points. 3 die, that many sample points. 4 die, that many sample points, right? Right? Times how many coins? 6 coins, 2 to the power 6. That is the, I solved one problem. Take a look at that one. So sample space, sample points. Then I discuss random variable. Probability distribution. Probability distribution of a random variable, mean and variance of a random variable, right? And then today I discuss conditional probability, conditional probability, independence, right? These are the things today I have discussed. Conditional probability, independence. These are the things I have discussed and finally solved couple of problems, right? How about if I take an exam on this, then it will be little, right? Because I'm not going to take any comprehensive exam. So next Thursday, not maybe next Thursday, maybe next Sunday. This will be not during the class time, okay? So read these 2-3 lectures, try to understand these 3 lectures, then your exam will be easier, because the next exam I will take only on probability distribution. So if I give you small material and test on a small material, then it will be easier to remember, right? Understand, right? So there will be an exam on it. Let me discuss one final thing, then I will stop the lecture today. 2 events what happened? Okay, take a look at that. 2 events A and B have following format. I want to ask you a question. Even in the graduate level, I ask this question. This is A and this is B. Okay? This is A and this is B. This is A, this is B. This is A, this is B. Understand? Now, A equal to what in here? A equal to HH, HT, and B equal to here HH, TT. So this is equal to HH, this is equal to TT, this is equal to HT. And please take a look what I am teaching. Understand? So during my class time, if you do not pay attention and use your computer, so that is not, if you take a note, that's fine, but try to understand what I'm doing. This is my A and this is my B. Here A equal to HH and TT. Here B equal to HT and TH. HH, TT, HT, TH. Understand? I want you to ask this question. By looking at this figure, figure 1 and figure 2. By looking at this figure, this is figure 1 and this is figure 2. Everyone ready? By looking at this figure, if I ask you to choose A and B are independent in figure 1 or A and B are independent in figure 2. This is the question if I ask you, and then I offer you a job after successful answer by a student. What would be your answer? A and B are independent in figure 1 or A and B are independent in figure 2? This is the question. Figure 2. You said figure 2. What about other? This is a 2 coin tossing experiment. 2 coin tossing experiment, and your sample space is HH, HT, TH, TT. Understand? One of your classmates said Figure 2, A and B are independent. What about other 6 students in the classroom? Let me come from the back. What is your opinion? Figure A or figure B? Figure 2? How about that boy? Figure 2. How about this boy? Figure 1. Okay, how about you? How about this girl? How about this girl? Quiet girl who doesn't want to speak more. Figure 1? Okay. Figure 1. Tell me what's the rationale. Why did you choose figure 1? Independent, did I say independence A union B?
No, the rationale, A union B steps. A.
I said A intersection B, not A union. Okay, what is your rationale?
So like figure 1 brings them both like together, I guess. Figure 2 like they're separate.
Good intuition. Good. Is this your thing? This is a very dangerous. This is Russia and this is Ukraine. Mutually exclusive. She said, if Dr. Chaudhary go to the New York, I'm not going. She's dangerous. She says she's not gonna go with me. Understand? Mutually exclusive. Mutually exclusive means if she will go for the coffee, I'm not going. So that means depends. My going to the New York, my going to the coffee shop depends whether she is going or not. So that means dependent, right? So that means if these things happen, that will not happen. We can check. This type of event, always dependent event, this type of event can be dependent, can be independent. Understand? Let's check. Let's check. So probability of A equal to what? 2/4 equal to half, right? In this case, probability of B equal to what? 2/4 equal to half, right? In this case, 2 sample point out of 4 sample point. So probability of A equal to half and probability of B equal to half. Clear, right? Are you understanding? Now, probability of A intersection B equal to what? Probability of A intersection B equal to what? In this case, what is that? 0, right? Because A intersection B, is there anything common? No, right? A and B, A intersection B means A and B. Is there anything common in A and B? No, right? So that means this is 0/4, which is equal to 0. Clear, right? So now take a look at that. I show the condition. What was the condition? Condition was that probability of A intersection B equal to probability of A times probability of B. That is the condition we are checking, right? Right? So this is equal to what? For this case, this is equal to 0. This is equal to half. This is equal to half. So it is equal to 4. Is 0 equal to 1/4? No, right? Left hand side and right hand side is not. So that means this is not. 0 is not equal to 1/4. Are you understanding? So I got here half, I got here half. This is the definition. Multiply this with that. This with that, I got 1/4, which is equal to 1/4. But that one is not equal to 1/4. That one equal to 0. So left hand side is not equal to right hand side. Clear? So left hand side is not equal to right hand side for this scenario. For this scenario, Clear, right? Now take a look at that one. In this one, probability of A equal to 2/4 equal to half. Probability of B equal to 2/4 equal to half. Now check probability of A, go to the up. Now check probability of A and B equal to A and B. What is common? Only one sample point, right? A and B has only one sample point common, right? What happened? Why did it disappear? So that has only one sample point common. HH, this is HT, this is TH, and that is TT. So this is A, this is B. Probability of A equal to 2/4 equal to half. Probability of B equal to 2/4 equal to half. And then probability of A and B equal to 1/4. Now check left hand side and right hand side. Left hand side equal to right hand side. Check. Left hand side equal to probability of A and B, which is equal to 1/4, and right hand side equal to probability of A times probability of B, which is equal to half times half equal to 1/4. So that means left hand side equal to right hand side in this case. You understand, right? So this type of case can be dependent, can be independent. But if there is no sharing, there is no touching, so that means that is mutually exclusive. That means exclusive. If she will take the course, I will not take the course. If she will go for the coffee, I will not go for the coffee. You understand, right? Mutually exclusive means is very dangerous. That is called dependent. On the other hand, this type of events could be independent, could be dependent by this simple example. And if the another this one, if these things I will put either here or here or here, you will see that will be dependent. If this sample point I will put either in there or in here or in here, then this will be dependent. And the compute the probability. So final words is what? This is the way. Anytime if I ask you, check whether two events are independent or not, you will do this times probability of B. Understand? If I ask one question, I'm going to ask in the exam, check whether two events A and B are independent or not, you are going to check these things. And then if left hand side equal to right hand side, then they are independent. If left hand side is not equal to right hand side, they are not independent. Clear? So I will set up a exam questions for you. That exams questions is coming from all the materials so far I have covered. I will upload this in the YouTube channel and I will send you the link. Watch the video, so your exam will be easy. Understand? Pay all of your attention, and what I do, you can pause the video and do it by yourself. What I'm doing, you will do it by yourself. Then your exam will be easy. Yes. Maybe not during the class time because I have to cover other materials. Maybe one weekend you can finish it. Once you log in, you have 2 hours to finish it. Okay, 10 to 15 or 20 questions will be given. Okay. So multiple choice questions will be given. You solve it and choose the right answer. Okay. Okay, everyone. So I'm going to stop in here if you do not have any other question.
Next Sunday.
Maybe next Sunday. You have enough time. So keep watching the video, okay? And start solving the problem.